Hi everyone, welcome to Study with Akshay and this is Akshay. In this video, we will be dealing with exercise 1B questions as well as MCQs. Okay, so basically, exercise 1B contains 11 questions and 2 MCQs. So it will become a lengthier video, so I don't want to make a lengthier video. I am dividing this exercise 1B into two sets. Set 1 containing question 1 to 7, set 2 containing question 8 to 11 along with 2 MCQs. So before getting started, if you have not subscribed to my channel, please do subscribe and hit on the bell icon to get regular notification. So let's not waste time, let's get started. And I also want to make you remind that exercise 1B contains all the questions related to our second video, center of gravity. So you can revise that video and then come back to this so that before I display the answer, you will be ready with it. Okay, so let's get started. Define the term center of gravity of a body. So what is this center of gravity? Center of gravity is a point about which the algebraic sum of moments of weights of particles constituting the body is zero, and the entire weight of the body is considered to act at this point. Okay, the point at which the algebraic sum of moments of weights of the particles constituting the body is zero is known as center of gravity. So make a note of it. So let's move ahead further with the next question. So yes, can the center of gravity of a body be situated outside its material of the body? Give an example. So we have to explain it with an help of an example. So yes, the center of gravity can be situated outside the material of the body. For an example, center of gravity of a ring. Okay, I have explained this in our second video. You can go back to that, listen to the detailed explanation and then come back to this. Let's move ahead further. State factors on which the position of center of gravity of a body depends. Explain your answer with an example. So yes, the position of center of gravity of the body of a given mass depends on its shape, that is, on the distribution of mass in it. For an example, the center of gravity of a uniform wire is at its midpoint, but if the wire is bent into the form of a circle, the center of gravity of a circle will then be at the center of the circle. So it basically depends upon the shape. That is the only concept we are explaining over here. So how come it depends upon the shape and why and all has been explained in the second video. And with an example, I have explained over here. Okay, it is self-explanatory. Since you know the concept of center of gravity, it will become more and more easier for you to understand. Let's move ahead further. So from here, we have a series of three questions, 4, 5 and 6. All these questions are related to the center of gravity only. And it is with respect to the center of gravity of the object. Like in this question, we have been given with rectangular lamina and the cylinder. In the next question, we have been given with some other two things and one more. Let's see as and when we go further. With rectangular lamina, rectangular lamina is at the point of intersection. The center of gravity is at the point of intersection of the two diagonals. So two diagonals can be drawn for a rectangle. So the point at which the two diagonals intersect is known as the center of gravity for that. Okay, then coming with a cylinder, the midpoint of the axis of the cylinder. So basically I had given a table as well while explaining the chapter. Go back to the second video, watch the table and note down the table. And while watching this video as well, keep a pen and a paper along with you to make running notes. You can pause the video, make the notes, and you can play the video. Okay, we'll go ahead next. At which point of is the center of gravity of situated? in. So yes, we have is a triangular lamina. First one we have over here as triangular lamina and a circular lamina. For a triangular lamina, the center of gravity of a triangular lamina is situated at a point of intersection of its medians, and for a circular lamina, it is situated at the center of the circular lamina. So these two we have already written in the table. It's just a recap, right? Once you know the table, it will be very easy for you to understand this, right? Next. Where is the center of gravity of a uniform ring situated? So where is it situated? It is situated in the center of the ring. Right. Basically, it's not within the material, it is outside the material. So next question. A square cardboard is suspended by passing a pin through a narrow hole at its one corner. Draw a diagram to show the rest position in the diagram and mark the point of suspension by a letter S. It is marked over here, and the center of gravity by a letter G. It is marked over here. So I myself on intention I have put this as a solution. So that you can only write the explanation for it. They have just asked us to draw a diagram. They have not asked us to explain. Right. So this itself is a solution. In order to gain the reader's attention, the evaluator's attention, you can write this. A square cardboard is rest with G as the center of gravity and S as the point of suspension, so that it makes the evaluator more and more clear that you are aware of the concept. Yes. So we are done with exercise 1B, set 1. Okay, we'll be continuing this with the 8th question in set 2 of exercise 1B. So before ending this video, if you have liked this video, please click on the thumbs up button. Please do share this video. You can comment on this video, and you can post any of your doubts, suggestions, or anything you want uh, to ask to me using the mail ID studywithakshay65@gmail.com. So before ending this, do follow COVID appropriate behavior, maintain social distancing, wear dual mask, sanitize at regular intervals. Together, let's all fight against this COVID-19 virus. Stay home, stay safe. Bye bye.